In this video, we're going to create a GKE cluster and use shared VPC. First of all, we're going to create two projects, host staging and Kate staging. Then we will create a shared VPC in the host project and share a subnet with our Kate staging project that will be used to deploy the Kubernetes cluster. The following approach is used to implement security best practices of least privilege for network administration, auditing, and access control. Alright, first of all, let's go ahead and create the folder Terraform where we're gonna keep all our Terraform files. And the first file will be provider.tf. And here we're going to define, first of all, the provider itself. And we're going to define the region as well. So I'm going to be using the US West 2 to deploy our projects and Kubernetes. Also, we're going to define another resource, the random integer. And here we're gonna say that this resource will generate random integer from 100 to 1 million. And we're gonna be using only for generating the unique ID for our projects. And this is pretty much optional just to automate this process. And finally, in this file, we're gonna define some Terraform constraints. For example, that certain providers, such as a Google provider, has to be compliant with our constraints. For example, version has to be higher than 3.66 and random provider has to be higher than 3.1. And that's pretty much it for this file. The next one will be the locals. All right, so in this file, we're going to define some variables that we're going to be using throughout all our Terraform resources. It's just much convenient to define variables and then not to repeat yourself, or just if you don't want to make a typo, you can define it under the locals and then use locals variables everywhere. All right, the first variable will be the region, which is the US West 2. Then we're going to need the org ID. And you can get that org ID from your GCP console. If you click, for example, here on the project, you can find the org ID here. So that's going to be your org ID. Let me use this. And also we need the billing account. Let's go to our organization, and here we can navigate to the billing and find our billing account ID. Let's use this one. The second variable will be the name for our host project, since we're going to be using the host and service projects. So we need some names. The host project, I'm going to call it the host staging, and service project will be Kate staging, where we're going to create our GKE cluster. And also we need to create the unique IDs for our project. It has to be unique throughout all the GCP platform. So that's why we're going to be using the random integer, the one from the provider.tf. And we can also cross-reference with the another local variables that we define in this block. So for example, here, host project, we're going to be using this host project, and then we're going to append the random integer. Same thing for the service project. All right, so, and the next variable will be project API. So here we're gonna define the API that we need to enable in both projects, in host project and in the service project container. So since we're gonna be using the shared VPC, we need to enable container Google APIs in both projects. And the last variable is the map of strings. Here we define first of all, just the name for the string, and we define the secondary IP range that will be used for the ports in our Kubernetes. So Kubernetes will allocate IP addresses from this range for the port IPs. And the second item in this map is the services IP range. And well, pretty much the same thing. This range will be used to allocate IP addresses for the services, Kubernetes services. All right, now let's go to the next file, and it's going to be projects.tf. New file. And we're going to be using the Terraform to create projects as well. not only resources in those projects. So to create the projects, let me define them first. All right, so you can use this link and get additional parameters that you can use throughout this resource. And for example, here I'm gonna say that I'm gonna create the host staging project. This is the name of the project ID, and billing account associated, and org ID. And also, I don't want to create any VPCs and subnets. I'm gonna use the custom mode and create them by myself. Same thing for the second project, Kate Staging. This project will be used for Kubernetes, and it's pretty much the same thing, just different name and different ID. And here I'm gonna enable APIs. For example, that API that we define in local variable, which is container API. All right. Now at this point, we can create a VPC. Let's create vpc.cf file. First of all, I'm going to create the VPC itself. So we're going to give it a name, main project. It's going to be created, the VPC will be created in host project. And I don't want to create any subnets by default. The routing mode will be region, and M2 will be 1500. Those are default values. You can use this link and find out more about those variables and update them if you want to. And the second resource in this file will be the subnets. So here I'm going to create one single private subnet for our VPC. We're going to call it private. And then we're going to define the project. So it's going to be deployed in host project, obviously, and then IP range for that subnet. Region, and then we're going to define and specify the network self-link. So this self-link comes from this resource. Here, this is the main resource, and this is the self-link of this resource. And also, since we need to create the secondary IP ranges, we have two options. The first option, just define inline those secondary IP ranges blocks. This is one of the way. And actually more advanced way, you can use, in at least in new versions of Terraform, you can use dynamic block, and you can use the map that we define in local variables and apply some actions to each of the item in that map. So since we have two items, the IP range and service IP range, we can use one single dynamic block and create those secondary IP ranges in one dynamic secondary IP range block. All right, that's all for this VPC. And the next file will be router. Router will be used for our NAT gateway, since we need to create the NAT gateway, and our pods and Kubernetes nodes have to have access to the internet to download, for example, Docker images. We need to create this router first, and then we're going to use this router to create the NAT gateway. It's pretty much straightforward. Just define, give it a name, region, project, and network. Now let's create the NAT gateway. All right, so here we're gonna again define the name for our NAT gateway, then the place where we want to, the project where we want to create this NAT gateway, the router, this is the reference to the router that we just created, and the region, then NAT IP allocation option after only. You have a couple of options. You can either allocate the static IP address yourself and then use it here, or you can allow NAT gateway to create and allocate public IP for you. And here, this option, we're gonna use this to provide routes to be able to use this NAT gateway in all subnetworks and all IP ranges. This is very important, since we create the secondary IP ranges for services and pods IPs. And since we're going to be using only one single subnet, we can use this option. Or you can define and you can actually specify what subnets you're going to use for that NAT gateway. So we don't want to create this NAT gateway before the subnetwork private is created. In that way, we can define this block here and explicitly depend on it. All right. The next option, all right, the next file will be shared VPC. All right, so we already have the VPC. Now we need to enable the host project and the service and attach the service project for our VPC. So the first one is to enable the host project. And here you just specify which project will be the host, which is the host staging. The second resource will attach the service project to the host project. And also it's required that we need to provide some permissions for our service account to actually use those subnets. For example, here I am binding. We're gonna say that we allow our service accounts from the key staging from our service project to use those subnets, the private subnet, to create the Kubernetes and create the instance groups, etc. This is the first I am binding, and the second I am binding is to use the another role, which is the host service agent user for our GKE. So those mandatory if you're not gonna create those bindings for the service accounts in Kubernetes project. You won't be able to use that private subnet from the host project. So those are mandatory. And finally, the last file that we're gonna create is actually the Kubernetes itself. Let's gonna call it kubernetes.cf. First, let's create the service account for Kubernetes. This service account can be used either for to grant some permissions for your pods, for example, to access just buckets, or this service account can be used to create the firewall rules for your pods. For example, you can use two filters, the service account and the pod IP range. Now the second resource will be the Kubernetes control plane here. So container cluster, we're gonna give it a name, region, and then specify the project. We're gonna say that we're gonna use the service project to create the Kubernetes and define the networking mode. It's gonna be the VPC native. Then we're gonna define what network we're gonna be using and subnetwork from the host project. We're gonna say that we want to remove default node pool and stuff like that. And here the release channel. This is very important to keep in mind that you're not gonna be able to disable completely upgrade of the Kubernetes master. You can only disable it for your instance groups. Here you can define the channel that you're gonna follow. You have the rapid channel, regular channel. So you need to decide what channel do you want to use for your master upgrade. Then you're gonna define the IP ranges. The first one will be used to allocate IPs for your pods, and the second one will be used for the services. Network policy, and then some configurations for the private cluster. So we not gonna enable private endpoint since we don't have the VPN or any other way to access it. Then we're gonna say that our instance groups, our nodes in instance group will have only private IP addresses, and then the seeder for your master control plane. Optionally, you can define the workload identity config, and this can be used to grant permissions on a pod level, not on the node level. So each individual pod can get the separate access to separate services. And finally, let's declare the instance group for our Kubernetes cluster. We're gonna only use one single instance group. We're gonna call it general. Then we're gonna define where we wanna create it, the reference for the cluster, then the reference for the project ID, initial node count. You can use autoscaling, or you can just define how many nodes do you want to use. Then after repair, you can just enable it. And with auto upgrade, you need to be careful. If you disable it, the master will keep upgrading no matter what, but your instance group you have to manually update your instance group. And if you enable it, it will just follow the master. Then some config for the node. For example, this one, we're gonna give some custom labels for those nodes and define the machine type and define the default scope for our instances. All right, that's pretty much it for the Kubernetes. And now let's go ahead and actually apply it. First of all, let's go to the terminal and change directory to Terraform. And before we can use Terraform, we need to make sure that we have the default credentials. And if you don't have it yet, you can run the following command: gcloud auth application default login. This will open the browser, and you just need to agree and allow the access. Let me show you. So for example, here you're gonna click here and then allow. All right, and then you can close the browser and you have your default credentials configured. Now you can use Terraform init. Well, first of all, let's run Terraform format to format our files. Then we're gonna use Terraform init command to download our providers. And optionally, you can run Terraform validate to validate your config before you can run plan. And let's run Terraform plan. So it's gonna create the 16 resources. All right, looks good for me, and let's apply. And let's agree and enter yes. So it's gonna take maybe 10-15 minutes to create this cluster. All right, now GKE cluster is created. Let's go ahead and take a look what we have now. Let's go to the GCP console and click on all, and we can see that we have two projects, the host project and staging project. First, let's go to the host. Here we should have the VPC. That's the VPC with the private subnet and secondary IP ranges. And in our second project, the service project, we have the Kubernetes. We don't have the VPC. We only share some subnets, private subnets, with this project. So let's go to the Kubernetes engine, clusters. And you can see that you have the Kubernetes cluster here in Kate staging project. All right, so the next step is to connect to this cluster. And to connect, you can click connect and copy and paste this command in your terminal. Go terminal and let's run this command. And now we have the config for our Kubernetes cluster. And to check the connection, we can run kubectl get svc, and we should have access to the Kubernetes API server. All right, so we do have connections. And if you type kubectl get nodes, you're gonna get, well, all those nodes. So since we defined the regional, and it's gonna deploy one instance, one node per availability zone. All right, and to verify our setup, let's create a simple application based on Nginx and create the public load balancer and try to access it. Let's go back to the code, Visual Studio Code. and create another folder. Let's call it kids. Now here, let's define the deployment file. It's gonna be just the basic deployment based on Nginx, and we're gonna use the default namespace one replica, nothing special here, right? And the second file will be the service. All right, so this is gonna be the type of load balancer. By default, it's gonna be the public load balancer and same default namespace. And let's go ahead and create it. Let's copy the path. Go to the terminal and type kubectl, apply -f, and provide the path for our Kubernetes files. And you can see that those two objects were created. Let's type kubectl get pods. In default namespace, we can see that we have the pod. And if you type svc, it's gonna take a while to create the load balancer, and then you're gonna get the IP address. But that's not all. Since we deploy this Kubernetes GKE cluster in our service project, this by default, this Kubernetes does not have access to create the firewall rules. But since it's a public load balancer, you have to create a couple of the firewall rules for the load balancer and for the health check. Optionally, you can grant this access to the Kubernetes, but I just want to show you that you would need to create those firewall rules yourself through the Terraform. And that's the whole point of using the host project and the service project. And the owners or people who have access to the host project only able to create those firewall rules. So this way you can centralize the network management. Now we have the public IP address, but if you're gonna go and check it, HTTP, and you're not gonna be able to access it. So it's gonna time out since the firewall role is not created. Let me cancel it. And to find out what kind of firewall rules you need to create, you can just simply copy and describe kubectl, describe, and then the service. And Kubernetes will tell you that you need to create two firewall rules. You can either just simply copy and paste this command, gcloud command, and run it, or I want to show you that you can actually use Terraform and create those firewall rules using Terraform. All right, to do that, let's go back and create additional file, the last file in our Terraform, and we're gonna call it terraform.tf. Here. And let me paste some boilerplate that we're gonna fill up. So here we have two rules. The first rule for the load balancer, to access load balancer. And let me see. That's gonna be the first one, right? So here we need to give it a name. The name will be, that's basically the name, right? Let's use this name. Then the reference for the network. This is the host project, and description will be, here is the description. And then we're gonna allow port 80, and targets will be, those are the targets tags. Those are the tags. Paste it here. And the second firewall rule is for the health check for those services. All right, so the second firewall will be called, that's the name of the second firewall. The same reference for the host network project. Description will be, that's gonna be our description. Then allow port 10 to 56, TCP, and then the IP addresses. Those allocated for the GCP, and you can expect the health checks coming from those IP addresses. And then we're gonna define the same target tags for our Kubernetes nodes. And that's pretty much it. Now let's go back to the Terraform and run Terraform apply again. And it will tell us that it's gonna create 2 firewall rules. All right, 2 firewall rules to add. Let's say yes. And those firewall rules created in the host project, not in the service project. Now, if you type kubectl get svc and grab this IP address for the load balancer, or we can just update this. Well, let me type HTTP. And now it works. So we created the firewall rules using Terraform as well. All right, thank you for watching, and please like and subscribe, and I'll see you in the next video.